In this example, we will examine the rational function f of x equals 2x minus 6 over x squared minus 8x plus 15. First, we will start by finding the domain of the rational function. Now, we know that when we have a rational expression, the denominator cannot equal 0. If the denominator equals 0, what that means is that the expression will be undefined. So if there is a value of x that would cause the denominator of this function to be 0, then the function would be undefined for that value of x. So what we have to do is we actually have to find all the ways where the denominator would equal 0, and then we have to remove those from the possible set of x values or remove those from the domain. So it's actually easier if we first identify the numbers that cause the denominator to be 0, and then we remove those, because there's usually only a couple values that are going to make the denominator equal 0. So instead of finding every single value that is allowed to be in the domain, we instead find the one or two numbers that are not allowed to be in the domain, and then we rule those out. So what we do is we take the denominator of the function and we actually set it equal to 0. And then we find out what values of x cause the denominator to equal 0. So my denominator is x squared minus 8x plus 15. If I set that equal to 0, in order to solve for x, I have to factor x squared minus 8x plus 15. That factors to x minus 5 times x minus 3. Then I use my zero product property to solve each of the binomials when they are set equal to 0. So x minus 5 equals 0. That gives me a solution of x equals 5. And then x minus 3 equals 0, which gives me a solution of x equals 3. So x equals 5 and x equals 3 are the two x values that we have to restrict from the domain. So those are the only two values that are not allowed to be in the domain. So what we can say then is that x equals 5 and x equals 3 are the excluded values from the domain. So that means x can be any number except for 5 or 3, or 3 or 5. So x can be any real number in the world, any number you can think of, as long as it's not 3 or 5. So I say x can be anything you want it to be, just make sure it's not 3 or 5. So let's take a look at what that looks like on a number line. So here is my number line that has any single real number I could think of. I've labeled where 3 and 5 would be, and I put open circles on 3 and 5. And then I shade everything to the left of 3. I shade everything in between 3 and 5. And then I shade everything to the right of 5. So my shading on the number line represents the numbers that are allowed to be part of the domain. And then the only two numbers that have to be restricted from the domain are where I have those open circles 3 and 5. So you'll notice my arrows that go to the left and to the right, those go out to negative infinity and positive infinity. So there's 3 sections of my graph that I have to include in my interval notation. So I'm going to write my domain right now. So the first section of my graph starts on the left at negative infinity, and it increases from negative infinity until the number 3. So the first part of the interval is from negative infinity to 3. Then I have to skip over the number 3. So I use the union symbol, but I can include the numbers between 3 and 5. So from 3 to 5, I want to include all those numbers, which includes 4, but it also includes 3.1, 3.2, 3.3, 4.5, 4.6, 4.7, 4.8, all the way up to 5, but not including 5. Then I jump over the number 5 and I start on the right side of 5, like 5.1 or maybe 5.01. And I can go all the way to the right towards positive infinity. So my third part of my domain is 5 to infinity. So my domain has 3 parts. The first part of the interval notation is negative infinity to 3. Then we have union. Then we have 3 to 5. Then we have union again. And then we have 5 to infinity. So that's how I would find the domain of this rational function. There is also a part B and a part C to this. We will continue this in the next video on a new slide.